Today we're looking at solving linear equations graphically. So far what we've been doing is solving linear equations using algebra, where we use inverse operations to get x on its own and then solve for x. However, one of the benefits for drawing up linear graphs is that you can solve for x by reading off the values from the actual graph itself. There are a few steps that we need to follow. The first step is to circle the y value in the equation. So if we had this example here, y equals 2x minus 4, we would circle the y value. And we do that so that we're actually able to remember the number that we need to now locate on the y-axis. So step 2 is to locate the y value that we've just circled on the y-axis. And we're then going to move horizontally, which basically means to move left or right till we actually meet the linear graph. And we're going to place a dot on the linear graph. And then from that point of the linear graph, we are then going to move vertically, so up or down, to find the value on the x-axis. And that's how we're able to actually find the value of x. We're going to go through an example of that now. So if we had the equation y equals 2x minus 4, we are now going to use the graph to solve each of these linear equations. So if we look at the first question, 2x minus 4 equals 2, what we've been doing so far is using inverse operations to get x on its own and then find the x value. However, today what we're going to do is we're going to use the graph instead. So the first step was to circle the y value. And from there, we're going to locate that y value on the y-axis. So if we look at our graph, we're going to go up the y-axis, 2. So here we are here. And we're then going to find that value onto the linear graph, and we're going to put a dot here. And from that point, we're now going to move up or down to meet the x-axis. And as you can see, it meets the x value of 3. So x in this equation equals 3. Let's try the next question. So this one is 2x minus 4 equals 0. Our first step is to circle the y value. From there, we're going to find it on our graph. And on our graph, y equals 0 at the origin. We're then going to move across to meet the line on the linear graph, which is here. We're going to put a dot here. And this time, we don't need to move up or down to find the x-axis because we're already on it. And as you can see, the value of x is 2. So for this particular equation, x equals 2. And one last one here, 2x minus 4 equals negative 6. So we're going to circle our y value. We're going to find that on our graph. We're going to move across till we meet the linear graph and place a dot. And then we're going to move up the graph to find the x value, which is negative 1. So the first step is to circle the y value. We're then going to locate that on the graph. We're then going to move across to the linear graph to actually find where it is on that line, and then we're going to find the x value. Now it's always good to check that we've read the graph correctly by checking it. And we're going to check using algebra. And all we're going to do now is we're going to substitute the x value that we read off the graph back into the original equation. So our equation here was 2x minus 4 equals 2. And what we want is, if I substitute x equals 3, we want both sides of this equation to equal 2. So let's do that now. So wherever there is x, I'm going to substitute 3. So 2 times 3 minus 4 equals 2. And we do BIDMAS, so we do 2 times 3 equals 6 minus 4 equals 2. And then 6 take away 4 is 2 equals 2. And as you can see, both sides equal 2, so what we read off the graph, which was x equals 3, is correct. So let's go back through those steps again. The first step is to circle the y value in the equation. We're then going to locate that value on the y-axis. We're going to move left or right till we find it on our linear graph. And then we're going to move up or down till we get to the x-axis. And then we're going to read off that value on the x-axis. And that is our answer to solving for x. And it's always good to check algebraically if that value is correct.